In this video, I'll be showing you how to sketch a linear function. Now, obviously, with the questions that have linear functions, where you have to sketch the linear functions, those usually count the most marks. So let's just get straight into the application of this. So the following function is given over here. We have y is equal to 2x plus 3. Now, as you can see, I'm using y as our output, where normally you would see output used as f of x. But in this case, what I'm going to be doing is I'm going to stick with y just for a couple more videos. And then once we get into the parabola, I want to try and use it until we get to the parabola, because I want to accommodate for the grade 9 students as well. So for now, I'm going to use y as the output, but if you are in grade 10, then you are expected to actually use f of x as the output value. So where do we start over here? Let me just get rid of this quickly. So where do we start? How do we start graphing this linear function? So the first thing that we can see, or the first thing that we need, is for the function to be in the form of y equals 2. I'm pretty sure you remember your teacher has told you this many times. In order to actually sketch a linear function, this is the form that your linear function has to be in: y equals mx plus c. If it's not y equals mx plus c, if it's not in that form, then you're going to have to manipulate the function such that you actually get that value. Or they're going to give you a random equation and you actually have to make y the subject of the formula. We'll go into another example after this one, and we can see how we can go about solving that. But for now, we can see over here in this question, given y equals 2x plus 3, we can clearly see that that is in the form of y equals to mx plus c. So where do we start? Where do we actually start? So the first two things that we have to look at, right, is going to be the gradient. If you can remember where the gradient was, the gradient is represented by the 2 over here, according to this equation. And the plus 3 is represented as plus c. This value doesn't just have to be plus, it can also be minus. If you can remember that the c value actually stands for y-intercept. That is how we represent y-intercept, by saying that it's the c value. So the first thing that we do in this case over here is we will plot the y-intercept. So I'm going to use red. So this over here is going to be red, the linear function. So where is the y-intercept equal to? Positive 3. Now, first of all, we need to indicate our axes as well. We need to label them. So we know that this is going to be the y-axis, and this is going to be the x-axis. Now, we can clearly see that we know that the y-intercept is the value that touches the y-axis. And let's just say that the positive 3 value will lie around here. Let's say that this is where positive 3 is. So therefore, or let's make it a bit lower just to accommodate for our space here. Let's say that this point over here is going to be positive 3, right? We're going to say that this over here is that is the y-intercept. I try to circle it as well, because what this means is that the graph is going to intercept that y-axis, and that's why we call it the y-intercept. Now, we got the point, but how are we supposed to do the straight line? How do we know which direction it's going to move? And that's exactly what I was trying to hint to as well. If we're talking about the direction of the graph, then we are talking about the gradient, because remember that the gradient indicates the slope, the steepness of the slope, and we know what the shape will look like. So in this case, we need to see whether the gradient is positive or negative. And we can clearly see that the gradient is positive 2. So therefore, it will actually be it will be increasing from left to right in that case. It will look something like that. So we can say it actually looks something like this, right? So we have our straight line. It would look something like this. But we can't do this immediately. And the reason why is because the easiest way to know our actual shape of this linear function is to actually find out where is our x-intercept. Remember, in the previous video on the introduction to linear functions, I spoke about a y-intercept and an x-intercept. We need to find out where the x-intercept is going to be. So we first need to do that before we can actually start graphing our linear function. So how do we do that? Let me do it over here. If we want to find the x-intercept, and I'm going to explain to you why. I'm not going to just give you the answer over here. I want to show you what we do in order to find the x-intercept over here. So, let's say that we have a random graph. I'm just going to do a different example here. If we have a random Cartesian plane, and let's say that we want to actually find, let's say, this value over here, right? Now, we don't know what this x value is. So our x value will be not undefined, sorry. We just don't know what it is. So it's unknown. And this over here will be, or let's just call it x actually. I think it's just better instead of using question marks, because we're doing algebra now. So we need to know our variables. So remember, this is the x coordinate, so we represent it as x. But what is our y value? Do we know our y value? If you can remember from the previous video, I indicated that on the x-axis, if there's an x-intercept, all the y values will always be equal to 0. Because it is in line with the value where y is equal to 0. In that case, where I just circled over here, in the origin. So therefore, on our x-intercept, our y value will be equal to 0. And the whole point of functions is to actually find an input. We input that value into the equation and we get a certain output. So in this case, our x-intercept is where we actually let y equal to 0 in that case. So therefore, we're going to start off by saying let y equal to 0. That is where we're going to start, the first step to find the x-intercept. You don't have to write this. You can actually just go straight to letting y equal to 0. So our equation was the following, right? We had y is equal to 2x plus 3. So therefore, over here, we can say 0 is equal to 2x plus 3. Can you see now that we only have one variable and we need to find that certain variable, and that variable is going to be x in that case. But in this case, we're actually talking about this graph over here. So let's try and find that x value. We need to solve for x. So our first step, if you can remember from the videos that I've posted on solving for x, we can just add both sides by 3, minus both sides by 3, so we can have minus 3 on this side over here, which is equal to 2x on its own. And therefore over here, we can just divide both sides by positive 2, so that we can actually cancel these out and have x on its own. And therefore we're going to have x is equal to negative 3 over 2. Yes, you can actually get fractions as answers. So that is what we're going to use as our coordinate in this case. So our coordinate over here is, or our x coordinate in this case, is negative 3 over 2. So that's how we're going to represent it. Okay, so then we can write it over here. Let's say our point is right over here, for example. And then we have it as negative 3 over 2. By the way, whenever you are going to graph a linear function, you should refrain from actually just putting in the regular values, because they normally want you to actually do it in coordinate form. So the y-intercept is actually the following. It's going to be 0 and 3, which is the y-intercept. And then the x-intercept, in this case, over here, is going to be, we know that our x value is going to be, or is, negative 3 over 2, and our y value is just going to be 0. So that is what we should actually represent it as. But because of space-wise, I'm just doing it like this on the graph. So we just plot our function from here. Okay, let's say that's this is our rough graph over here. Okay, now we can clearly see that we have our graph. So that's actually how we graph a linear function. There's nothing really difficult about that, but we are missing something, and this is also what I want to say that's important. If you're in grade 10 and you are given that this equation actually starts with f of x, like instead of y they say f of x, then you do the following. When you are labeling it, you would just say f. This graph is actually named f. But if you are in grade 9, they want you to actually write down the full equation. So they say that this equation is going to be exactly what they're given you. Y is equal to 2x plus 3. 2x plus 3. Nothing too difficult about that. And those are the steps that you need to take in order to graph a function. Let's do one more example and then we can call it for the video. Alright, so we have our final application for how to graph a linear function. So we are given the following equation. 4x is equal to y minus 5. Now we can clearly see there's something wrong with this one. Remember when I told you before we have to sketch the graph of a function, we need to get it in the form of y is equal to mx plus c. Now, is this one in the form of y equals mx plus c? Obviously it's not. So what we need to do is we need to actually get y on its own. And I think I gave a little bit of an easy one for this one, but I assume that you should know how to solve for x for some of these ones. I don't want to go too much into detail. I'll leave the difficult questions for the examination type based questions or videos in that case. So I'm just doing this for example's sake, so that I introduce you to the fact that we are not just always given the formula or the equation. So what we need to do, we need to just solve for y in this case. Okay, so over here, remember the equation over here is 4x. So it's 4x is going to be equal to y minus 5. And obviously, in order to get into y equals mx plus c, we need to get y on its own in this case. So we need to make y the subject of the formula. So what we are going to do, we're going to add 5 on both sides, such that y is on its own. And then we're going to have 4x. Did I say minus 5? I meant add 5. I think I said add 5 on both sides. But we're going to add 5 on both sides such that we get y on its own. So it's going to be 4x plus 5. And note how we always write down this in this order over here, where we have 4x first. Basically the coefficient with the variable, it shows first, and then the constant goes second. Because that actually gives us the form of y equals to mx plus c. And now that we got it in that form, I'm just going to write it down so we have the equation. Okay, so here is our equation. Y equals to 4x plus 5. Now we need to start plotting this. And remember, the first thing I told you to look at is first the y-intercept, because then we know what exactly we need to plot down. So the y-intercept is positive 5. Now where is positive 5 in the y-axis? Let's just assume it's somewhere over here, right? So maybe here. So we're going to say that positive 5 lies over here. What I'm going to do for practice purposes, I'm just going to randomly add like a negative over here, right? I know that doesn't make sense, but at the same time, I want to actually just show you the different types of gradients that we can actually get, because I want to expose you to all these types of questions. So for now, I'm just going to add that negative there. It's not going to be a big issue, but please, whenever you're in an exam, please don't just tell the teacher, I'm going to add the negative there because I want to look cool, because they're pretty much going to give you a 0 for that question. So yeah, I don't recommend it. Anyway, so I just added a negative 4 over there so I can show you that we'll actually have a different type of graph. Well, I mean, it's still going to be a linear graph, but right now it's going to look different. Okay, so first of all, what we need to look at over here is we don't just look at the gradient and say, oh, now I can graph it. No. I mean, sure, you can look at the sign in front of it, the negative or the positive, to see which direction it moves. But first, we need to find the other intercept. So we were given the y-intercept, but we need to find out where is the y-intercept. Is it on this side, or is it going to be somewhere on this side? And that's what we're going to find out. So once again, we're going to try and determine the x-intercept. And how do we do that? So if you remember from our previous example, over here we had the x-intercept. Normally I would indicate it like this. The x-intercept, like I've shown you, we are going to let y equal to 0. Now, After we let y equal to 0, we take our equation and we're going to say it's going to be 0 is equal to, I made negative 4x plus 5. That is our equation. Now we need to solve for x. And I've completely forgot to get rid of this. Excuse me, let me just do that. Okay, cool. Alright, now we need to solve for x. Now, to make this a little easier, because we don't like to work with the negatives, what I'm going to do is I'm going to add both sides by positive 4x in this case. So it's going to look like this. It's going to be plus 4x, because I don't think I've exposed you to adding both sides or minusing both sides by a variable with its coefficient. So it's going to look like this basically. So there. So obviously this side is then just going to have 4x. And then this is going to be equal to, and then obviously these two can cancel out of here. Minus 4x plus 4x just gives you 0. And then we have 5 on the one side on its own. Now we can divide both sides by the coefficient of x, and then we can cancel these out over here, such that we actually get x on its own. Now we have x is equal to 5 over 4. And that is our x-intercept. So now we need to plot that. So positive 5 over 4 is just above 1, so let's just put it over here. So this one is going to be 5 over 4. Now what we can do is we can actually see, what did we do the right thing? Let's first look at the sign of the gradient, right? It's a negative. And what do we know about negative gradients? If we have a graph like this, we know that negative gradient is decreasing from left to right. So therefore, it actually should look like this shape over here. And does it look like this shape? Let's just draw the graph so that we can actually have them connect the dots over here. So this should look something like that over there. It must obviously pass through the intercepts that we have. So as you can see, the graph is indeed decreasing from left to right in that case. So therefore, we have plotted our function, but we haven't finished yet. Remember, we have to label it as well. We're going to say that this is equal, y is going to be equal to negative 4x plus 5. Now, you probably have a question saying, but Dylan, what about this? What about this equation over here? Do we use that equation? No, you don't use that equation, because that is just a random equation that was given so that you can actually make sure that y is the subject of the formula. Because remember, you have to have the function, the linear function is in the form of y equals to mx plus c, so you have to follow that rule. And that is what your label should look like. And obviously, if you're in grade 10, you would, if you're given the function f of x is equal to the function, or sorry, the equation over there, or the expression, my words, then you would label this as f, or whatever function, variable, or letter that you were given, maybe g or h or whatever. And that is how we plot a function, a linear function to be exact. And in the next video, I'll be going over the gradients, and as well as determining the equation. Well, I think actually let me just deal with the gradients for that video, and then I will be dealing with the rest of the stuff. So the next video will be on gradients, and how do we calculate gradients.